Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Noizati binti Anas Anizan. I'm currently in 6th semester. I'm from School of Electrical Engineering, College of Engineering in UiTM Shah Alam. My main supervisor is Associate Professor IAF Dr. Joanna Johari, TS Dr. Fazlina Ahmad Ruslan, TS Dr. Nafazli Abdul Razak, and my last co-supervisor is Dr. Muhammad Aziz Abdul Aziz. So today, I would like to present my progress report for this semester, which is entitled Improvision of Faster RCNN for Vehicle Infrastructure V2I in Urban Traffic Environment. So next, we starting from problem statement. Currently, high processing controller have been used in executing faster RCNN, which model that can improve the accuracy. Next, for scope and limitation, my scope for this project is using high processing controller, and my limitation is limit the project is work in urban traffic environment. So this is the research question that I have made for myself to complete the project. So the research question is include the data collection, image recognition, accuracy testing and validation, real-time processing, machine learning, model training, and the last one, integration with vehicle system. So all those research question is made for myself to asking myself to complete the project. So for objective, there's three objectives, and the first one is to generate the data set of traffic signage and roadside units in metropolitan city. Second, to generate the faster RCNN technique for detection and classification of traffic signage and roadside units. Third, to compare the developed technique with the established faster RCNN. So next, I will explain about different of CNN, RCNN, fast RCNN, and faster RCNN. What is the difference of all those techniques? Okay, so for CNN, also known as conventional net, CNS typically has three layers, which is first a conventional layer, second a pooling layer, and third a fully connected layer, FCL. So conventional layers works by placing a filter over an array of image pixels, pooling layer for reduced dimension and computation, while fully connected layers to perform classification on dataset. By the way, those convolution layers have value, which is rectifier linear unit layer to help with making on model nonlinear and act as activation function. In short, value is like a filter for those dataset. Second, RCNM. Choose ROI in a rectangular boxes purpose area from selective search. RCNN then it passed to a pre-trained CNN model, and the output or feature maps are passed to FVM for classification. And finally, the regression between predicted bounding box are ground truth are computed. For a fast RCNN, it passes the original image to a pre-trained CNN model once, then its search selective algorithm is computed based on the output feature map of the previous step. Then our eye pooling layer is used to ensure the standard and predefined output size. These valid outputs are passed to a fully connected layer as inputs. Finally, two output vectors are used to predict the observed object with a softmax classifier and a depth bounding box localization with a linear regression. And the last one, faster RCNN. Three-stage deep learning object detector. First is passed to region to a convolutional neural network layer. Second, search selective process that have in fast RCNN is replaced by RPN region proposal network. And last, output feature maps are passed to a support vector machine for classification, regression between predicted bounding box and ground truth. Bounding boxes are computed. Next. So This is the difference between CNN vs RCNN, as I explained just now in words. But now I want to show you in diagram, so it's more easier for you to understand what is the difference. So as you can see, CNN, when it get the data set, the picture or the data set first, then it will have to do a convolutional layer plus value. Then the picture will be pulling to reduce all the dimension and computation. Then we get the output, which is convolutional and value. Then we pulling once again, and the last one, it will go to the network, which is, oh, is this a koala or if this a head on body? From the eyes, nose, ears, and all the body parts, it only takes 2 or 3 body parts only. Then next for RCNN, as you can see, RCNN, when we get the data set or the picture, first they will make a ROI or region of interest from a proposal method. Then from the ROI, they will do a CNN from this region of proposal method. Then it pass to a pre-trained CNN model. Then the output passes to SVM for classification, and the lastly the regression between bounding boxes and gone truth are computed. So the next one is fast RCNN and faster RCNN. So as you can see, the faster RCNN, just now the RCNN make the ROI first and pass to CNN model. But faster RCNN, it make the CNN first. It pre-train the CNN model first. Then from the pre-trained CNN model, the output of the picture, it will use ROI or using a selective search on this pre-trained data set, then making a ROI pooling layer. Then it will go to fully connected layers for classification, and the linear soft and the lastly softmax classifier and adapt bounding box localization will be predicted. And the last one is faster RCNN. So faster RCNN, as you can see, the dataset and picture will go to CNN. It is same as fast RCNN, but the picture, but after the model is trained by CNN, and as you can see in fast RCNN, it will use selective search, means just use a purpose area, which area that you want to use. But in faster RCNN, we use RPN, region proposal network, from the pre-trained CNN model picture. So from the picture, we taking the sum proposal from the picture, and then the output will go to the classification and bounding box. And also from the pre-train, we go to ROI pooling to match either the RPN just now is same as the ROI pooling. Oh, okay, so the classification and bounding box regression box is computed. So this one is architecture RPN or region proposal network in faster RCNN, which is the different from the fast RCNN. Fast RCNN using the selective search in pre-trained CNN model picture, but however faster RCNN using a RPN. Okay, as you can see, the RPN, we are not select some proposed area to do, but it only just use a one area, then take it anchor or layer, and usually we are using from the area we'll using a care anchor box, mean from the layer will divided to certain box or to certain dimension for for detect, oh, this is the koala, oh, this is, so some parts only are taken. So this next I will show the data set statistic that I have using. So in this project, I'm taking a custom data set, which is by using a mobile phone and using a Google Street Image and Google Image. So the image size is different, is different between the sources that I'm using. So this one is the framework uh, for my project. So as you can see, the process and the next step that I have to use for everything that in project to make the project is smooth and complete. So that's all for me. Thank you.